Alright, so welcome back, and in this lecture we'll be looking at the concept of linear regression. So I'll introduce you in this lecture to the concept of linear regression. So let's begin. Well, first look at the history behind it. So linear regression was first observed by a man named Francis Galton, who was investigating the relationship between parents and their children. So he particularly investigated the relationship between the heights of the fathers and their respective children. So he observed that a son tended to be roughly as tall as his father. However, he observed one more. He had one more observation, which was a breakthrough, and he observed that the son's height was roughly equal to the overall average height of all people in the family. Golden called this phenomenon a regression and said that the son's height tends or regresses, meaning it drifts towards the mean average height of all the people in the family. Let's take an example. So here we have two data points, A and B, and the regression line is the one which is closest to the points in the x and y direction. So as you can see, this is the line which is closest to the points in the x and y direction, and these are the points A and B, and this line, blue line, is the closest one to in that direction. Alright, so it was simple and it is 100% accurate. However, if you have a lot of data points, for example a cluster of data points, however, we need to use machine learning in order to predict the height of one son even before he or she is born. In such a case, in order to find the right fitting line, which means this line, which line would fit rightly, we need to use the least squares method, which is fitted by minimizing the sum of the squares of the residuals. So this might seem a bit complex to you, but let me explain. Okay, sum of the squares is very simple to understand, but residuals, what's residual? So in statistics and machine learning models, residuals is the difference that is observed and predicted values of the data, which means that it is something that is observed. It's the difference between something which is observed or the difference between the predicted values of the data, which gives them the title errors, which means that there is an error in the model, not any kind of Python errors that you get. It's lack of error here refers to lack of accuracy of the model that we have built. So residual is the difference between the observed data and the predicted values of the data. For example, in the last lecture we observed that the data said that we had 9.6% accuracy. That means 4%, we have 4% residual, we have 4% of residuals, so they are known as errors. So finally we have the formula, which is y is equal to a plus bx, where y is equal to the dependent variable, which means a variable in the y-axis, in the x is equal to the independent variable, which means the variable in x-axis. So as you can see, this is the x-axis, this is the y-axis. The variables in this y-axis is known as is the y, is the variables in the x-axis is the x. Alright, so b is the slope of the line. Slope refers to the curve of the line. Here it's 0. Alright, and a is the y-intercept. Now y-intercept is the value at which x is equal to 0. So thank you very much for listening to this course, and I hope you liked it.